Select the major product of the following reaction. So we have an aldehyde reacting with a primary amine, and we have a trace amount of acid, so we can read this as a slightly acidic solution. And we also have in here sodium cyanoborohydride. So let's take a look at that structure. So this looks really similar to sodium borohydride that we have encountered as a mild reducing agent previously. So this certainly has the look of a reducing agent. So let's first consider what we've seen previously with aldehydes or ketones and primary amines under slightly acidic conditions. So we have seen this, that an aldehyde or a ketone can react with a primary amine under slightly acidic conditions. So you might see that slightly acidic being written as like a trace amount of acid. This is just below pH 7 and around pH 4 to 5, so sometimes you'll see it written that way. But what we know is that that's going to take an aldehyde or a ketone and give you an imine under those conditions. So it's safe to assume that this aldehyde and this primary amine with a trace amount of acid are going to give you an imine. And so what the imine structure is you're basically taking this nitrogen and snapping it basically exactly where that oxygen was. So here is the imine structure then. So the carbonyl carbon is still going to be in the same oxidation state because it's going to have a double bond still to a more electronegative atom. It's just going to be nitrogen instead of oxygen. So we have a double bond to that nitrogen. And because it's a primary amine, we still have the double bond between the carbon and the nitrogen, and we've lost along the way, and we could draw the whole mechanism, though it's pretty long. You lose those two hydrogens ultimately. So you're losing two hydrogens and an oxygen, so you're actually losing water when you take an aldehyde or a ketone and you form an imine. But so we lose the hydrogens, we don't lose the R group. So we need to make sure this R group is still attached to that nitrogen. So this would be the imine that you form. And so we want to think about what the consequences of also having what looks like a reducing agent in here. And this is a really mild reducing agent. So this is able to reduce actually the iminium ion that we formed before this with the positive charge, but not the aldehyde or the ketone. So it's going to reduce this so that you're going to get the amine product out of this. So with your mild reducing agent, you're going to snap this in place with the double bond, and then imagine that you get rid of that and put a hydrogen on there. So you're going to get the amine, which is this compound here, A. Okay. So with this mild reducing agent, let's just take this further and draw this product here. So instead of the double bond, we'd have a single bond to the nitrogen. So it's now going to have a lone pair of electrons. You added an extra hydrogen right here. So this now has two hydrogens. Previously, there was just one hydrogen, right? So that second hydrogen is coming from your hydride reagent, and then you're still going to have that R group on there. And so this is a really, really nice way, and also we're actually adding a hydrogen to our nitrogen as well. So let me make sure I have that on there. So we're adding basically H2 across that double bond. So this is a really nice way to take an aldehyde or a ketone and directly make an amine. And so this is known as a reductive amination. So you can do this reaction with either an aldehyde or a ketone and either a primary amine or a secondary amine, and you will reduce it to the amine product.